Standing in the Bekaa Valley of Lebanon, about 85 kilometers northeast of Beirut, you'll find the ancient site of Baalbek. Most tourists come here to photograph the towering Roman columns of the Temple of Jupiter, some of the best preserved Roman architecture in the world. They snap their pictures, maybe grab a coffee, and leave thinking they've seen another impressive ancient ruin. But underneath those Roman columns lies something that makes engineers stop and stare, something that seems impossible given the technology we attribute to the ancient world. We're talking about stone blocks that weigh more than 800 tons, fitted together with such precision that you cannot slide a credit card between them, forming a foundation platform that exists beneath the Roman structures but clearly predates them. The Romans were master builders, absolutely, but these stones, they never claimed to have moved them, and modern engineers, with all our technology, struggle to explain how anyone did. The foundation platform at Baalbek, known as the Trilithon, consists of 3 limestone blocks that each weigh approximately 800 tons. That is 1.6 million pounds per block. To put that in perspective, the Statue of Liberty weighs about 225 tons. We are talking about stones that each weigh more than 3 Statues of Liberty. These blocks measure roughly 19 meters long, 4 meters high, and 3 meters deep. They are positioned about 6 meters above ground level in the western wall of the temple podium, fitted together so precisely that archaeologists have described the joints as nearly invisible. The blocks sit roughly 20 feet in the air, locked together in a configuration that would challenge modern engineering. And then there is the stone of the pregnant woman, still in the nearby quarry, weighing an estimated 1,000 tons, partially carved from the bedrock but never moved. Next to it lies the Stone of the South, discovered in the 1990s, estimated at 1,200 tons. In 2014, researchers found another block, even larger, estimated at 1,650 tons. These are not just big rocks. They are precisely shaped architectural elements, cut with flat surfaces and right angles, abandoned mid-process as if the builders simply stopped and walked away. The conventional explanation suggests the Romans built the entire temple complex, including the massive foundation stones. The Temple of Jupiter at Baalbek was constructed during the reign of Augustus and continued through several emperors. Roman engineering was remarkable. They built the Colosseum, the Pantheon, massive aqueducts spanning valleys. They understood concrete, arches, leverage, and organized labor. But here's the problem. Nowhere in the extensive Roman architectural record across an empire that spanned 3 continents and lasted centuries is there any mention of moving stones this size. The Romans kept detailed records of their engineering achievements. They documented their construction techniques, their tools, their methods. When they moved the Vatican obelisk, weighing about 330 tons in 1586, it required 900 men, 75 horses, and massive wooden frameworks, and the event was celebrated as an extraordinary engineering feat. That was with Renaissance technology, 1,500 years after the supposed Roman construction at Baalbek. The Vatican obelisk weighs less than half what each Trilithon stone weighs, and moving it was considered one of the greatest engineering accomplishments of the era. Think about what moving an 800-ton block actually requires. Modern heavy lift cranes, the kind used to position segments of bridges or lift components of nuclear reactors, typically max out around 1,000 tons. The Tyson crane in China, one of the largest in the world, can lift 20,000 tons, but it is a fixed installation the size of several buildings, powered by electricity and using advanced hydraulics and computer-controlled balance systems. A 2014 study by the German Archaeological Institute examined the quarrying and transport logistics at Baalbek. The researchers calculated that moving an 800-ton block would require either rolling it on wooden logs, which would need perhaps 500 to 1,000 men coordinating perfectly, or dragging it on sledges, which would require even more workers. The coefficients of friction, even with optimum conditions of water-lubricated clay pathways, make the math troubling. you are talking about a coefficient of friction around 0.3 to 0.5, meaning you would need to apply a horizontal force of 240 to 400 tons just to overcome static friction and get the stone moving. That is before you account for the slight uphill grade from the quarry to the temple site. But the transportation problem is just the beginning. These stones are positioned approximately 6 meters above ground level. How do you lift 800 tons to that height? The ramp theory, frequently offered as an explanation, creates its own cascade of problems. To achieve a manageable incline, let us say 10 degrees, which is already quite steep for moving such weight, you would need a ramp roughly 34 meters long to reach a height of 6 meters. That ramp would need to be wide enough for the stone and stable enough to support not just the stone's weight, but the combined weight of hundreds of workers and whatever transport mechanism you are using. We are talking about a temporary structure that would itself require thousands of tons of material, all of which would then need to be completely removed after construction, since no archaeological evidence of such ramps remains at Baalbek, and that is assuming a straight ramp. The site's topography and the position of the stones in the western wall suggest the approach would have been more complex, possibly requiring switchbacks or multiple ramp stages, each multiplying the engineering challenges. Here is what makes engineers particularly uncomfortable: precision. These 800-ton blocks are fitted together with joints so tight that researchers have measured gaps of less than a millimeter in places. This is not rough stonework, where you stack blocks and fill the gaps with smaller stones and mortar. This is precision fitting that requires both blocks to be shaped with flat, true surfaces and then positioned with extraordinary accuracy. Modern stone cutting for precision applications uses diamond-tipped saws, computer-guided CNC machines, and laser measurement. The tolerances we are seeing at Baalbek would be impressive for modern work, let alone for a culture working with bronze or iron tools. Bronze tools are softer than limestone in many cases, meaning they would deform faster than they would cut efficiently. Iron tools are harder but would still require frequent resharpening when working on this scale. And we are not talking about cutting 1 or 2 blocks. We are talking about quarrying, shaping, and moving multiple stones of extraordinary size, plus hundreds of smaller blocks, some still weighing 50 to 300 tons, that form the rest of the podium. The Roman explanation gets even more problematic when you look at the architectural sequence. The massive foundation stones are part of a podium that supports the Roman temples, but the construction style of these megalithic blocks is markedly different from Roman work. Roman construction typically used smaller stones with mortar, concrete, or the opus quadratum technique, where squared stones of manageable size are stacked in regular courses. The megalithic foundation does not match this pattern. It matches something older, something that appears in other ancient sites around the Mediterranean and beyond, places where massive stones were moved and fitted with similar precision. The Temple of Jupiter was built on top of this platform, using it as a foundation, suggesting the Romans found these stones already in place and built upon them. Roman writers do not mention constructing the foundation. They mention restoring and expanding the temples at Baalbek, but the megaliths themselves are not credited to Roman engineering in contemporary sources. Pliny the Elder, who wrote extensively about Roman achievements and was not shy about giving Rome credit for impressive engineering, mentions Baalbek but does not attribute the massive stones to Roman work. In the quarry, roughly 800 meters from the temple site, the unfinished stones tell their own story. The stone of the pregnant woman, at 1,000 tons, is still attached to the bedrock along one edge. It has been completely shaped on 5 sides, with smooth, flat surfaces and precise right angles. The cutting marks are visible, showing where workers chiseled along the base to separate it from the quarry floor. But it was never finished, never moved. The stone of the south and the even larger block discovered in 2014 are in similar states, partially separated from the bedrock, precisely shaped, abandoned. These stones are not rough quarry blocks that would be shaped at the building site. They are finished architectural elements ready for installation, each one representing thousands of hours of labor with primitive tools, and yet they were left behind. Why? If you have the technology and organization to quarry and shape a 1,650-ton block, presumably you have the ability to move it. The presence of these abandoned stones suggests either the project was interrupted suddenly or the builders encountered a problem they could not solve. Either way, it indicates that moving these stones was difficult even for whoever originally cut them. The archaeological dating at Baalbek is complex and contentious. The Roman temples are clearly Roman, dated to the 1st through 3rd centuries CE by architectural style, inscriptions, and historical records. The massive foundation platform has been harder to pin down. Some researchers argue for a Phoenician origin, dating it to around 1000 BCE. Others suggest it could be even older, potentially to the Bronze Age, which would push it back to 3000 BCE or earlier. The challenge is that stone does not contain organic material that can be carbon dated, and the megaliths themselves do not have inscriptions identifying their builders. What we can say is that the foundation appears to predate the Roman construction, based on architectural discontinuity, different construction techniques, and the fact that Roman sources treat the site as already sacred before they built there. The name Baalbek itself means city of Baal, referring to the Phoenician god, which suggests the site had religious significance long before Rome arrived. The Romans renamed it Heliopolis, meaning city of the sun, and built their temples on ground that was already considered holy. A 2010 study by researchers at the University of Munich used ground-penetrating radar to examine the subsurface at Baalbek. They found evidence of earlier structures beneath the Roman temples, including walls and foundations that predate the Roman period. The radar imaging showed a complex of earlier buildings, some of which aligned with the orientation of the megalithic platform, but not with the later Roman temples. This suggests a long history of construction at the site, with multiple civilizations building on top of earlier work. The megalithic platform appears to be the earliest monumental construction, later used as a foundation by Phoenicians, then by Romans, each culture building upward on the previous layer. The question remains who had the capability to move and position stones weighing 800 tons with precision fitting, and when they did it. If the answer is the Phoenicians or an earlier Bronze Age culture, we have to reconcile that with the fact that there is no evidence of comparable megalithic engineering from these cultures anywhere else. The Phoenicians were master sailors and traders, known for their purple dye and their alphabet, but not for moving stones of that size. Modern attempts to understand the construction have involved both theoretical modeling and practical experiments, none of which have fully resolved the mystery. In the 1960s, a team of engineers calculated that moving the Trilithon stones would require approximately 40,000 workers if using rope and wooden rollers, based on assumptions about the pulling force each worker could apply and the friction coefficients of wood on stone. That number is staggering, representing a labor force larger than many ancient cities' entire populations. It would require not just the workers, but a massive logistical support system to feed them, house them, and coordinate them. And that is just for transportation. The lifting problem remains separate. Some researchers have proposed that the stones were levered into position using a system of counterweights and fulcrums, essentially a massive seesaw arrangement where workers would stack weight on one end to lift the stone on the other. The problem is that you would need a lever arm extraordinarily long to move 800 tons, a fulcrum that could withstand the compression forces without crushing, and counterweights that themselves would need to be substantial. The engineering would be theoretically possible but practically nightmarish, requiring precision and coordination that seems unlikely given the tools we believe were available. What is particularly striking is the pattern. Baalbek is not unique in having massive, precisely fitted stones. At Sacsayhuaman in Peru, limestone blocks weighing over 100 tons are fitted together with similar precision, using a polygonal fitting style where each stone has multiple faces shaped to lock with its neighbors. The builders did not use mortar, yet the blocks have withstood earthquakes for centuries because they are so tightly fitted. In Egypt, the Valley Temple near the Sphinx uses blocks of granite, some weighing 200 tons, fitted together and faced with smooth precision. The Temple of Jupiter at Baalbek uses limestone, but the principle is the same. Massive stones, precise fitting, no mortar, positioned above ground level. On Easter Island, the Moai statues are not quite as heavy. the largest transported one weighing about 82 tons, but they were moved across the island and erected on platforms, and we still do not have a definitive explanation for how islanders with limited resources accomplished this. The Olmec heads in Mexico, each carved from a single basalt boulder weighing 20 to 40 tons, were transported from distant quarries across rivers and swamps. There is a global pattern of megalithic construction across different continents, different cultures, different time periods, all sharing the common feature of moving and positioning stones that challenge modern engineering. The implications are unsettling for conventional historical narratives. If we attribute the Baalbek foundation to the Romans, we have to explain why they never moved comparable stones anywhere else in their vast empire, why they never documented this achievement, and why the construction style does not match Roman techniques. If we attribute it to the Phoenicians or an earlier culture, we have to explain where they developed this capability, why they never used it elsewhere, and why there is no archaeological evidence of a learning curve, no evidence of earlier, smaller megalithic projects that would represent them developing the technique. Instead, the megalithic platform at Baalbek appears fully formed, as sophisticated in its engineering as anything that came after. This is a recurring pattern in archaeology that makes researchers uncomfortable. The earliest pyramids in Egypt, the pyramids of Giza, are the most sophisticated. Later pyramids are smaller, less precise, as if the engineering knowledge declined rather than improved over time. At Baalbek, the massive foundation stones are the oldest element, with later construction using progressively smaller stones. It is as if the capability to move blocks of 800 tons existed at one point and then was lost. There are researchers who have proposed alternative explanations, ranging from the scientifically speculative to the fringe. Some suggest ancient cultures had access to technologies we do not recognize in the archaeological record, methods like stone softening or acoustic levitation that would leave no trace. Others point to the possibility of lost civilizations with advanced engineering knowledge, precursor cultures that predated the Bronze Age societies we know about. These ideas are controversial, and they are not accepted in mainstream archaeology, primarily because we lack physical evidence of such technologies or civilizations. But the stones at Baalbek remain as physical evidence, evidence that is measurable, photographable, and inexplicable using the tools and techniques we believe were available to ancient cultures. You can stand there, put your hand on an 800-ton block positioned 6 meters in the air with millimeter precision joints, and know that someone moved it there somehow. The stone does not care about our theories or our limitations. It is there. The German Archaeological Institute has continued research at Baalbek using photogrammetry and laser scanning to create detailed three-dimensional models of the megalithic stones, with measurements precise to the millimeter. These models reveal not just the size and positioning of the blocks, but also tool marks and quarrying techniques. The stones show evidence of being shaped using point chisels and possibly saws, techniques we know ancient cultures possessed. But the scale at which these techniques were applied is unprecedented. Cutting a 19-meter-long stone with flat, true surfaces using hand tools would require not just skill, but extraordinary patience and quality control. Any deviation from flat across that length would create problems when fitting the stones together. Modern stonemasons working on far smaller blocks for restoration projects have described the difficulty of achieving truly flat surfaces with hand tools. It is possible, absolutely, but it is time-intensive and requires constant checking with straight edges and levels. Multiply that challenge by the scale of the Baalbek stones, and you are looking at years of work per block, all of which then had to be transported and lifted. So what are we left with? We have stones that measurably weigh 800 tons or more. We have evidence they were quarried, shaped, transported approximately 800 meters, and lifted approximately 6 meters to be positioned with precision fitting. We have conventional explanations that require labor forces numbering in the tens of thousands, temporary structures that would themselves be massive engineering projects, and coordination that would challenge modern construction management. We have no contemporary accounts from the cultures we attribute this work to explaining how they did it. We have unfinished stones in the quarry, even larger than the ones that were moved. suggesting the builders either faced limitations or the project was interrupted. We have a pattern of similar megalithic construction at sites around the world, all challenging our understanding of ancient capabilities. And we have modern engineers who, with all our technology, would struggle to replicate this work today. The largest stone moved in modern times using historical methods was a 340-ton block, moved to Thailand in 2012 for a memorial, requiring steel rollers, hydraulic jacks, and computer modeling. It took months to move 300 meters. The Baalbek stones are more than twice that weight. The foundation at Baalbek exists. It is not a myth or a legend. It is limestone bedrock that was quarried, shaped, and positioned by someone at some point in human history. The stones have weight, dimensions, and positions that are measurable and verified. The question is not whether it was done. The question is how and by whom, and whether our current understanding of ancient civilizations' technological capabilities is incomplete. Every explanation requires you to accept something difficult. Accept that ancient cultures, with tools we consider primitive, performed engineering that would challenge us today. Accept that there may have been knowledge or techniques that were not preserved in the archaeological record. Accept that perhaps we have underestimated what humans could accomplish with organization, ingenuity, and determination. Or accept that there are aspects of human history we simply do not understand yet, gaps in our knowledge that these massive stones represent. The blocks sit there in the Beqaa Valley, fitted together with precision, weighing more than anything the Romans documented moving, positioned by unknown hands at an uncertain time. You can visit them, measure them, photograph them. What you conclude is up to you.